Number 21 says, what are the electron geometry and molecular geometry of chlorine trifluoride, ClF3? Electron geometry and molecular geometry. In order to answer this question, we need to be able to draw this molecule. Alright, here we go. And actually, the way that I'm going to go about this is I'm going to just try something random because we may not know exactly how to approach this molecule and its geometry. And what I'm going to do is wrong at first, but then we're going to correct it and end up with the right answer, because that's how you might go about it on your test. Is you might try something, it might be wrong, but you could tweak it just a little bit, try something new, and end up with the right answer. So we need the geometry. Since there's only one chlorine, that's probably going to be the central atom. There are multiple fluorines, so they're probably going to be the atoms that surround the central atom. Okay, I have a central chlorine. Now I have a few different ways of orienting the fluorines, so I'm just going to pick some arbitrary way. I'm going to have a fluorine. I'm going to have a fluorine out here to the right. I'm going to have a fluorine that is coming out of the board at an angle near my face. And then I'm going to have a fluorine going into the board with this dashed line. Pretty much that's on the other side of this board, like, you know, into the wall, still in line with my face, but in the board. Okay? I'm going to erase these bonds for just a second. That's just to show you where they are. In order to make the Lewis dot structure, we need to take a look at our electrons. How many valence electrons would this whole molecule have? 7 come from the fluorine, 7 fluorine, 7 fluorine. 7 come from the chlorine. So that's 4 sevens, gives me 28 valence electrons available for bonding. I know that the fluorines and the chlorine will all have to bond. Like this. So that's going to take 2, 4, 6 of my electrons away. I have 22 left for bonding. Okay? Now I need to fill each fluorine's octet and eventually the chlorine's octet as well. Here we go. 2, 4, 6. If I put 6 electrons around this fluorine, it now has 8. 1, 2, 3, 4, 5, 6, 7, 8. Count each bond as 2 electrons. Okay? 2, 4, 6. 2, 4, 6. How many electrons did I just throw on? 2, 4, 6, 8, 10, 12, 14, 16, 18. I just threw in 18 electrons. I only have 4 available for bonding. Here's my little electron counter. We are now accountants. Congratulations. I have 4 electrons left, but my fluorines can't take any more electrons. Therefore, my chlorine must. Alright, I put 1 on top, 1 on bottom to keep it even. We don't want to bunch up electrons. Electrons don't like to be together. And so now we have to analyze the geometry of this. There are 2 types of geometries. There's electron geometry and molecular. Electron geometry considers the electrons. Molecular has nothing to do with electrons. So here's the electron geometry. Electron geo. What would it look like? Again, I want to emphasize that this fluorine-chlorine bond is a bond that's coming out of the board like towards my face from the chlorine. And this fluorine-chlorine bond is going into the board. Okay? So that these 3 fluorines, they're in a plane to each other. The electrons are above the plane, and these electrons are below the plane. The electron geometry, I'm going to draw them as sticks. So here would be my central chlorine, and then I'm going to draw sticks connecting the electrons and the electrons to the chlorine, the fluorine to the chlorine, the electrons to the chlorine. Here we go. So this is the stick that represents the electrons to the chlorine, the fluorine to the chlorine, the electrons to the chlorine, and then I have this stick coming out towards me, and then a stick going into the board there. So what shape is this? This would be, let's see if I can draw this. What I'm doing is I'm connecting these fluorines to that fluorine, making a triangular base, and then I'm going to connect the fluorine, fluorine, fluorine up with the electrons up here. What this is doing is this molecule is creating a certain shape in space. Alright, what we have here is we have a triangular base with a pyramid up top and a pyramid on bottom. This pyramid is on bottom because I have electrons on bottom, and I need to consider the electrons for the electron geometry. So this would be trigonal because it's a triangular base, right here, this triangular base that I originally drew. Bipyramidal, because I have two pyramids, one on top, one on bottom. What would the molecular geometry look like? The molecular geometry would ignore the electrons. So then we just have the central carbon connected to the right fluorine, connected to this fluorine sticking out towards me, and then the fluorine that's into the board, all in a plane. Since it's all in a plane, and it makes the shape of a triangle, see this? It's a triangle. That's trigonal planar. Your teachers might say trigonal, it's all the same, whatever. I think trigonal sounds more aristocratic. Okay, so you look on your test and you don't see this combination. Why not? That's because we've drawn the atoms around the chlorine in the wrong positions. So we're going to tweak this just a little bit. Stick with me. Instead of putting the electrons on top and bottom, maybe I could replace these electrons with fluorines. Fluorine up on bottom and fluorine up top. And then I could replace these two fluorines, it really doesn't matter which fluorines you replace, with electrons. The two electrons that we originally had. Electrons, electrons. And let's see what this would do to the geometries. So would it affect the electron geometry? I don't think so. We still need to take these into account. We need to take the fluorines into account. It'd still give us the trigonal bipyramidal. But what would it do to the molecular geometry? We wouldn't have this trigonal planar because now the fluorines are oriented like this. One fluorine to the right of the chlorine, and then a fluorine above and below the chlorine. That's T-shaped. And we do see this answer on the test. That is answer number 4.